Welcome children. Today we are going to see the class 9 maths, the chapter triangles part 3. In earlier classes part 1 and part 2 we have seen the triangles and its the properties and also the congruence rule. So these are the first 3 rules. First, SAS. You know what is SAS? Side, angle, side. Okay. And then ASA, angle, side, angle. And then AAS. So these two rules, congruence rules, are same, but the difference is the side is not included between two angles. What here? ASA, in ASA congruence rule, two angles and one side is included between these two angles, whereas in AAS congruence rule, two angles and one side. Therefore, any two angles and any one pair of corresponding side. So like that you have to take. So SAS congruence rule, ASA congruence rule, AAS congruence rule. So far we have seen up to that, and after this we have learnt the properties of isosceles, properties of an isosceles triangle, that you know. There are two properties. First one is angles in an isosceles triangle, angles opposite to equal sides are equal, and in an isosceles triangle, sides opposite to equal angles are equal. So that we have seen. And now in exercise 7.3, these two rules are applicable. Triple S, congruence rule, and then RHS. RHS means when we try to prove a theorem or any problem, left hand side, right hand side may be there. So like that RHS means you don't think here right hand side. Okay, here in triangle RHS congruence rule, that means R represent right angle, H represent hypotenuse, and S represent one side of that right angle triangle. Clear? So RHS rule means right angle, hypotenuse, and one side. Clear? And now we will see that triple S congruence rule. If three sides of one triangle, so we have to take two triangle and we have to compare three sides of one triangle with the three sides of another triangle. If the pair of three sides, corresponding sides, pair of three corresponding sides are equal in two triangles, then we can say that two triangles are congruent triangles. Okay. So if three sides of one triangle are equal to three sides of the other triangle, then the two triangles are congruent. For example, you take triangle ABC and another triangle PQR, and if the sides, corresponding sides AB correspond to PQ, BC correspond to QR, and AC correspond to PR, and they are equal. AB equal to PQ, BC equal to QR, and AC equal to PR. If it happen, then we can say the two triangles are congruent. Triangle ABC congruent to triangle PQR. Is it clear? Triple S congruence rule is applicable, but I already in the first class itself I told you triple A congruence rule is not there. Okay, I explained about it also. Clear? Angle, angle, angle. If three angles of one triangle are equal to three angles of another triangle, we cannot say that two triangles are congruent. It is not given there, but for information I am telling you. So triple S means side, side, side. So three sides of one triangle is equal to the three sides of another triangle, then we can say that two triangles are congruent. And now coming to RHS, I already explained you what is RHS. So RHS congruence rule. If in two right triangles, we have to take two right angled triangle. So simply we can say it right triangles. So here I put capital R and then I put dot and then I have wrote triangles. So that means right triangles. Clear? If in two right triangles, hypotenuse and one side of a triangle, okay, are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. For example, you can take ABC, a right angle triangle, PQR, another right angle triangle. So compare this. Already we have the 90 degree here in triangle ABC, angle B is 90 degree. In PQR triangle, angle Q is 90 degree. So one pair of angle is 90 degree, they are equal. And then hypotenuse, what is the hypotenuse of this triangle? AC. And what is the hypotenuse of this triangle? PR. Therefore hypotenuse are equal, AC equal to PR. You see, these two angles are 90 degree, so they are equal, and hypotenuse AC is equal to hypotenuse PR. Simply we can put AC equal to PR, but for your reference I am telling you that hypotenuse AC is equal to hypotenuse PR. And one side, for example, you can take BC, either AB or BC. So out of these two sides, any one side. So if you take BC here, and it should correspond to QR in next triangle. So if BC is equal to QR, then triangle ABC congruent to triangle PQR. Is it clear, children? So like that you have to remember that rule. So in 7.3 we are going to apply these two rules and also the previous congruence rules also, all these. Clear? These three also for the proof sum. To prove a sum, we have to apply all these rules, okay, wherever needed. So we have to apply these rules. So you should remember all these. These are the 5 congruent rules, and this one, you know, two are not alike, but if you see the name of the letter AAS, two angle one side, here also two angle one side, but this is included side, this is any one pair of side. So that's all. So totally these are the congruence rule given here in your book. So exercise 7.3, let us see. And now exercise 7.3. So before that, you take the notes as per the chart I have shown to you. So you take that. After copying that, you come to this exercise 7.3. First sum. A triangle is given, the diagram is given in the book itself. In this triangle ABC, AB, AC, these two sides are equal sides. Okay, and then here D is a point inside the triangle but above BC. Okay, BC is the common base for ABC and DBC. It is given. Both are isosceles triangle. It is given in the question. So these two sides are also equal. Just I am putting the double mark. These two sides equal because it is given DBC is also isosceles triangle on the same base BC. So DBC, the base is BC. For ABC also the base is BC. Now AD is extended to P to meet BC. Okay, AD is extended to P to meet the BC. Okay, it is given in the book. So we can have that AB equal to AC, DB equal to DC because both are isosceles triangle. To prove the first option, triangle ABD, totally there are 4 options there. So first one, triangle ABD congruent to triangle ACD. So this you have to prove. So just you take ABD this triangle, okay, and ACD this triangle. So these two triangles you have to take. Okay, so from this we have AB, or you can write that in triangle ABD and triangle ACD, what are the things we can collect? AB equal to AC given because isosceles triangle. Okay, it is given, and then BD equal to or dB, anything you can take, dB equal to DC. So, this is also given. And then one more thing, AD, the side AD is common for both triangles. So, AD equal to AD, common side. So, now 3 sides of one triangle is equal to the 3 sides of another triangle. So, we can easily say the 2 triangles are congruent. This implies triangle ABD congruent to triangle ACD. By what rule? Triplus rule. Okay, by applying the triplus rule, side, side, side. So, we can say these 2 triangles are congruent. And now, option 2, to prove triangle ABP congruent to triangle ACP. You look at the figure, ABP is one triangle and another one you have to take ACP. Clear? You have to observe what triangle we are writing there. And now, in this triangle we can take AB and this triangle we can take AC. Okay. So, AB equal to AC, this is given. Okay. And then you see AD is common. So, you can take AD equal to AD, that is common. Sorry, ABP. So, AP have to take, AP is common side in both triangle ABP and ACP. AP is the common side. And one more thing, what we can take means these 2 angles we can take, but you have to say these 2 are equal. Is it clear? You have to say these 2 angles equal. How to say? Because in the previous proof these 2 triangles are congruent, ABD and ACD. From this we can have, this implies in this triangle we can say BAD angle, which is equal to CAD angle. By CPCT we can say, okay, these 2 angles are equal. You know why? Because these 2 triangles are congruent. So, we can have these 2 angles are equal by CPCT, and this you can take as BAD angle is nothing but BAP, like that also you can take, because AB is extended to P. So, we can have BAP angle is equal to, like that here also, CAD, which is extended to P, means CAP, angle will not change, only the name from D to P is changing. So, CAP. So, this is also we can have it and can name it as, so that the name in equation you can put that this is equation number 1 and this is equation number 2. And now let us come to the second part, the second proof. To prove these 2 triangles are congruent, already we have these 2 corresponding sides are equal, and now we can have these 2 angles from from the equation 2. From the equation 2 we can have these 2 triangles, these 2 angles are equal. So, we can take BAP angle is equal to, that is CAP. You see BAP from this triangle and CAP from this triangle, these 2 angles are equal. The reason, from equation 2 you put 2 and circle it, that is called equation. So, from this equation we have BAP equal to CAP. So, 2 pair of sides and 1 pair of angle. You see these 2 sides and this angle means that is nothing but included angle. Okay, so you can apply that rule SAS. So, the triangle ABP congruent to triangle ACP, the rule you can apply SAS rule. Clear? by applying this rule, we can say these two triangles are congruent. And now coming to the next option 3, you see what is there? AP bisects angle A as well as angle D. To prove AP bisects angle A as well as angle D. So, this is what we have to prove. Clear? AP, where is it? AP bisects angle A means this angle A. So, AP bisects angle A as well as angle D means these two angles. You see here, we have to say these two also bisected by AP. So, first we have to say AP bisects angle A. So, where we can say, you see, BAP, CAP are equal to, already we have proved, no? This one BAP equal to CAP. From where we have taken? From equation 2. So, you can again take from proof, we had right, proof, in proof part, from equation 2 we can write in words. Now, from equation 2 we have BAP equal to CAP. These two angles equal, isn't it? So, now after saying these two angles equal, then AP bisect angle A. This implies AP bisects angle A. Now, it is proved. And now again we have to say AP bisect angle D also. For that we have to take which one? These two triangles are congruent, we have to say, because here only you have to say these two angles are equal, then only you can say AP bisect angle D also. For that you have to take these two angles, these two triangles. What are they? BPD and CPD. Clear? If these two triangles, if you prove congruent, then we can say easily that by CPCD these two angles are equal. After that AP bisect angle D, like that we can say. So, we have to think by observing the diagram. So, you have to think what we have to do first to prove the given proof. So, first you take these two triangles. What are the equal things we can have directly? So, in these two triangles, that means what I am saying, B, P, D and C, P, D. So, in these two triangle, this is rough work I am doing, okay, for your reference. These two triangle, we have this already DB equal to DC, DB equal to DC, and then DP is common, okay, DP equal to DP, and one more thing we have to say what is that, okay. So, DP is common and this BC side, you see BP and PC, we have to try to say another pair of sides BP and the CP, either they equal or not. So, for that if you try to say that, then we can say the two triangles are congruent. For that we know in part 2, the option 2, these two triangles are congruent, am I right? So, from that we can say, after saying triangle ABP and ACP congruent, okay, you can say by CPCT this BP and CP are equal. Since, so first of all you have to take, since triangle ABP congruent to triangle ACP, okay, we proved no already. By CPCT we can say BP equal to CP, CP, CT, we have it, clear. By applying this we can say these two triangles. First you consider in triangle BPD and triangle CPD. So, what things we can have? Already we said that dB equal to dc, given, it is given, and then dp equal to dp, common side, common, and then here bp equal to cp. By cpct we have said it. So bp equal to cp, we have it. Okay, otherwise we can name it also, either equation 3, let it be equation number 3. So from 3 we can have it. Okay, from 3 we have bp equal to cp. So by triple S congruence rule, these two triangles are congruent. Triple S rule, by triple S rule we can say BPD triangle is congruent to CPD triangle. So why we tried to say these two triangles are congruent? Then only by CPCT we can have B implies B DP is equal to angle CDP, CPCT. After proving these two triangles are congruent, we can say these two angles are equal by CPCT. So these two angles are equal, we just proved that BDP angle is equal to CDP angle. Then we can say this AP bisect angle D also, DP bisect angle, first you can say in these two triangles DP bisect angle D. This implies DP bisects angle D. Okay. And so AP bisects angle D. So like that we can say, because DP is along the line AP only, line segment AP. So we can say if DP bisects angle D, AP also bisect angle D. So hence last we can say AP bisects angle A as well as angle D. That's all. And now one more proof is there. Fourth one, AP is the perpendicular bisector of BC. Okay, that you will see. So now coming to the option 4, to prove AP is the perpendicular bisector of BC. AP is the perpendicular bisector of BC, the base BC. Okay, that means perpendicular bisector means AP should make angle 90 degree with the base BC. Am I right? So we have to say these two angles are 90 degree. Is it clear? So this is 90 means this also 90. So like that we have to say. And then BP equal to PC already we have. You see BP equal to CP. Okay, already have in equation 3. So we can take in the proof part that since triangle ABP and ACP, ABP and ACP, because AP means it makes two triangle, no, ABP and ACP. So since ABP and congruent to, already we have proved congruent to ACP, triangle ACP, we have BP equal to CP, that is also CPCT, and angle, you see which angle, this one, that angle is APB, APB, this angle and this angle. Okay, or you have to say this 90, so you can put the mark 90 degree symbol. Okay, but you have to show it that they are 90. APB, angle APB is equal to angle APC. This is also by CPCT we can say they are equal. Now we have proved that they are equal by CPCT, because these two triangles are congruent. So by CPCT we can say ABP angle is equal to angle APC. Clear? By CPCT we can say, but we have to show each is 90. Then only we can say AP is the perpendicular bisector. Perpendicular means what? To make 90 degree, angle 90 degree. Okay. So for that, you see, this is a line, okay, and this is a line which cut the given line. So these two angles are what? Linear pair of angles, that you know. So by applying that concept here, ABP, APB plus APC is equal to 180 degree. In bracket we can write that linear pair of angles is 180. But APB and APC are equal, so we can replace it, any one by replace the other. Okay, so I am taking that APB as it is, and I am replacing, okay, APB instead of APC, because they are equal, 180. Now we can write 2 angle APB 180 degree. So APB, so therefore angle APB is equal to 90 degree. If you bring to the right side, it becomes 180 by 2, then you get 90 degree. This implies, now you can substitute here, APB equal to APC, both are 90 degree. Okay, because this is equal to this. By applying this, we can write both angles are 90, each angle is 90. So now we can say these two sides, that the segments are equal, BP and CP are equal, and also AP makes 90 degree with the base, therefore AP is the, so P is the midpoint now. Okay, so AP is the perpendicular bisector of BC. This implies AP is the perpendicular, this symbol stands for perpendicular bisector of BC. So like that we can easily prove it. So that's all. So now question number 2. So given AD is the altitude of an isosceles triangle ABC with AB equal to AC. So you see ABC is an isosceles triangle with the AB and AC are equal, and AD is the altitude, means what is the altitude? Which makes, okay, the line segment AD which makes 90 degree, the perpendicular distance also you can say. Altitude means the perpendicular distance. Perpendicular distance means what? This AD should make 90 degree with the base BC. So that is called the perpendicular. So AD is the altitude, means the perpendicular distance from this vertex A to the base BC is called altitude. So we can have these two triangles, these two angles are 90 each. So they are asking to prove AD bisects BC. So given you have to take AB equal to AC, and AD bisects BC, you have to show. Here we can say ADB, angle ADB equal to ADC. Okay, that is equal to 90 degree, because they have given that AD is the altitude of BC. And now you take in triangle ABD and triangle ACD. Okay, these two triangles I am taking, and I want to prove they are congruent. So for that we have AB equal to AC, that is given, okay, and then AD is common, AD equal to AD common side, and then angle ADB is equal to angle ADC, because 90 degree, that also given, you know. Okay, now this is hypotenuse. 90 degree means what? Right angle triangle. So right angle is there, 90 degree, and then AB equal to AC. So which is the hypotenuse? of this triangle AB for this triangle AC. So, hypotenuse are equal and one side is equal. So, we can say they are congruent by RHS rule, these two triangles, triangle ABD congruent to triangle ACD by which rule? RHS rule. Okay, one right angle, one hypotenuse and one side. So, now option 2. So, sorry, we have to say AD bisects BC. After proving these two congruent, we can say BD of this triangle and DC of another triangle, they are equal by CPCT. This implies BD of this triangle is equal to CD of the next triangle ACD by which property? CPCT. Okay, the corresponding parts of congruent triangle. So, after proving these two sides, these two sides are equal, BD and CD, we can say AD bisects BC because these two are equal. So, this implies AD bisects BC. And now option 2. So, you have to say AD bisects angle A. This AD bisects angle A means you have to say these two angles are equal, these two angles. Clear? How to say that? To prove AD bisects angle A. So, how to prove that? You see, since these two triangles are congruent, since triangle ABD congruent to triangle ACD, okay, what you can take? Angle BAD of the first triangle is equal to angle CAD of the next triangle, right? By CPCT we can say that. Therefore, what? AD bisects angle A. Is it clear? That is all the proof, and we move to the next sum. And now coming to question number 3, two triangles are given, okay, and the given thing is AB equal to PQ. AB of this triangle is equal to PQ of the another triangle. BC equal to QR. This mark represents the full triangle, full side BC is equal to QR, and AM PN, they are equal. What is AM and PN? It is given that they are the medians of the triangle, each triangle. AM is the median of triangle ABC, PN is the median of triangle PQR. So, now we should know what is the median. So, the before sum we have learnt altitude. So, what is altitude? I said altitude means line segment joining a vertex of a triangle to a point on the base. That means the point perpendicular, it makes perpendicular, that means angle 90 degree with the base. Okay, the line joining a vertex and the base, the point on the base which makes 90 degree with the base BC, that is altitude. But whereas median means it is also the line segment joining a vertex of a triangle, here A, to the midpoint of the opposite side. Clear? So, now if you take vertex A, what is the opposite side of A? BC, and M is the midpoint of BC, and if you join vertex and the midpoint of the opposite side, then it is called median. So, AM is the median, therefore, M is the midpoint of BC. Okay. So, M is midpoint of BC and N is the midpoint of QR. Then only if you join the midpoint and the vertex, you get median. First of all, you should know what is median. Okay. So, in the proof part, since AM is the median of triangle ABC, comma, M is the midpoint. Okay, midpoint of BC. This implies BM CM equal, or we can have BM is equal to half of BC, like that we can have. Okay, and since what you can say, next one, PN is the median. PN is the median of triangle PQR, comma, N is the midpoint. Midpoint of QR. Okay. Now we have QN is equal to half of QR because this midpoint. So QN is half of QR. So let it be equation number 2. Comparing 1 and 2, what we can write from 1 and equation 2, we can say this is half of BC and this is half of QR, but we have before that we can say, but BC is equal to QR, and from 1 and 2 we can write that is half of BC is equal to half of QR. No, if BC equal to QR, then we can write half of BC, half of the BC and half of QR also equal. So from 1 and 2 we can say half of BC and half of QR equal means BM equal to QN. This implies BM is equal to PN from 1 to 2. Here you can write the reason from 1 and 2, because half of BC is equal to BM and half of QR is equal to QN, but we have shown here half of BC and half of QR both equal. Therefore, half of BC is equal to BM and half of QR is equal to PN. Sorry, it is QN. Sorry, ma. This is QN. So half of QR is equal to QN. Therefore, BM is equal to QN. So like that we can say. Can you understand this? Okay. And now, after saying this, BM and QN are equal, from these two triangles, we can write in triangle ABM and triangle PQN. So, what are the comparison? We can take first of all these two triangles, okay, this one and this one, because we have to show these two triangles are congruent. AB equal to PQ. This is given. And then AM equal to PN, that also given. And BM is equal to QN, proved above. Okay, you have to write proved above this one, BM equal to QN. And now side by triplets rule, triangle ABM congruent to triangle PQN. But what rule? By triplets rule we can say these two triangles are congruent. And after that, second option is there. We have to say the second option, ABC congruent to PQR. To prove triangle ABC congruent to triangle PQR. So, how to prove this? So, look carefully. So, ABC PQR. In that we have AB equal to PQ, that is given, no? AB equal to PQ, and BC equal to QR, that also given. And one more thing we have to say. So what is that? You see this angle and this angle. If you say the angle B and angle Q are equal, then it is easy to say that two triangles are congruent. How to say that? Since these two triangles are congruent, since triangle ABM congruent to triangle PQN. So what can we say? ABM angle is equal to angle PQN. This is by CPCT, that you know, isn't it? By CPCT we can say this ABM angle and PQN angle are equal, because we have proved above that these two triangles are congruent. And now ABM angle we can name it as ABC, because BM just extended up to C. Am I right? So you can write that as ABM as ABC also. No wrong. So nothing wrong is there. So ABC angle is equal to PQN also in the same way PQR we can write. Okay, these two angles are equal. So therefore, easily we got one pair of angles equal, and you can write now in triangle ABC. Now we can take these two triangles to prove that congruent. PQR. So what are the things we say? AB equal to PQ given. The reason you have to write clearly given. And the next, BC equal to QR, that also given. And now we have proved these two angles are equal. ABC angle is equal to PQR. We can give the name as no more equation there, 1, 2. So now we can name it as 3 and write from 3. From 3 means the equation 3. Clear? From equation 3 we have ABC angle is equal to angle PQR. So now two pair of angles, two pair of sides and one pair of angle, and that also included angle. From the figure we can observe that angle is included angle between these two sides. Okay, so we can say by SAS rule they are congruent. This implies, okay, triangle ABC congruent to PQR. The reason by SAS rule, the reason you write the right side, no space there, so I am writing below that. So by SAS rule we can say ABC triangle is congruent to PQR triangle. So this is the way to prove, and two more sums are there. It is very easy. Okay, so you take as homework 4 and 5, and this chapter is over because the rest of the exercise are deleted for you. So up to this you take this, and worksheet also you have to finish it then and there. Thank you.